In math class, the following quantities 2.0, 2.00, 2.000, and so forth probably would be counted all the same and could be used as simply the number 2. However, when we're dealing with measured quantities, as in science class, when we actually take measurements, the number of digits that show up within the measurement indicate the degree of precision of that measurement. And it's important to be able to keep track and properly record the number of significant figures or digits within a number that refers to a measurement. So as we have these numbers that are laid out here with increasing number of digits in the form of decimals, we're referring to an increasing precision, which will be the topic of another short video. So why do we need to count significant figures? Well, the answer to that is that when we do calculations with measured quantities, we must be able to count the number of significant figures within the numbers. Now, significant digit rules do not apply to exact quantities. And examples of exact quantities of pi, which is not limited by significant figures, it's a number that seemingly goes on forever, and one can keep as many decimal places as one likes. Another example of an exact number would be 2 people, or 1 mile exactly, 1 meter, 12 inches, or 1 foot. These all refer to exact quantities where rules of significant figures do not apply. One method of counting significant figures involves imagining a map of the United States where the Atlantic Ocean is on the right and the Pacific Ocean is on the left. And this is just a mental map or a way to remember the letter P and the letter A, which can also refer to whether or not a decimal place is present in the case of the Pacific Ocean or absent in the case of the Atlantic Ocean. And what this refers to is our first rule for counting sig figs in measured quantities, and that is approach the number from the appropriate side based on whether or not there is a decimal point. And so if the decimal place is absent, we approach the number from the right side, and if the decimal point is present, we approach it from the left side. So here we have examples of numbers that some have decimal points and some don't. And all of the ones with decimal places we approach from the left side when we count the number of significant figures, and all of the numbers that we have that don't have a decimal point we approach from the right side. The second rule is that we move through the digits in the number in the appropriate direction to the first non-zero digit, and then count that digit and all the other digits in that direction, including zeros. So let's take a look here at the side that all have decimal points present. For this number, we approach the number from the left side because the decimal is present. We go to the first non-zero digit, which is a 2, and we count that digit and all other digits, including zeros, in that same direction. So here we go. There's 1, 2, 3 significant digits in this number. The second number we have here, we apply the same rule. There's a decimal place present. We approach it from the left side. We go to the first digit that is not a 0, which is right here. It's the 2. We count that digit and all other digits, including 0, in that direction. So this number has 4 significant digits. In our last example with a decimal place, we approach the number from the left side. The first number is a non-zero. That means we count it and all the other digits in the number in that direction, making 5 significant figures in this number. Looking at the ones that do not have a decimal place, we approach the number from the right side. The same rule applies. We go to the first digit that is not a 0. We count it and everything else in that direction. In this case, there is nothing else in that direction, and this number has 1 significant digit. 30 feet, we approach that from the right, go to the first thing that's not a 0, we get the 3, that's again 1 significant digit. 23,450 meters, go to the first non-zero digit, which is the 5, count the 5 and everything else in that direction, and we get 4 significant figures. For numbers that are properly expressed in scientific notation, the coefficient, or the part that comes before the times 10 to the whatever, the coefficient contains the number of significant digits in the number. So there are 2 digits with the coefficient here. That makes for 2 significant digits in the number. Here we have 3 significant digits, again 2, and in this case 4 significant digits. So if the number is expressed properly in scientific notation, then the coefficient that's out in front tells us the number of significant digits. Thank you. Pictures for school, take 2.